Hello, math students. Mr. B here. I'm going to give you a little more insight and detail into nth roots here. To start with, there's a couple rules that a lot of people kind of gloss over, but they're important. And here's one of them. If we have the nth root of a to the n, this actually equals the absolute value of a if n is an even number. So you're taking an even root of a number. But if you take the same root, you get a without absolute values if n is odd. So let's see some examples of these. You can see what I'm saying. So examples of 1. Examples of case 1 there. So let's say we have the fourth root of 3 to the fourth. Well, the rule just says we have to have the absolute value of the thing we have to the fourth power under the radical. And the absolute value of 3 is just 3. Okay. What if we had the fourth root of the quantity negative 3 to the fourth? This is not an even root of a negative. This is an even root of negative 3 to the fourth power. The rule, number 1, says that we have to have the absolute value of the thing being raised to the fourth power, which again is 3. Now, does this make sense? The fourth root of 3 to the fourth is like asking what is the fourth root of 81, and that is 3, positive 3. What about the fourth root of the quantity negative 3 to the fourth? Well, negative 3 times negative 3 times negative 3 times negative 3, 4 negatives makes a positive. So this again is the same thing as above. It's the fourth root of positive 81, which we know is 3. So we can see that the absolute value is important here. What if we have the fourth root of x to the fourth? Then we don't know the sign of x. Absolutely. Like in this positive case, the first one, it didn't matter. We didn't have to have the absolute value because it was a positive number. But we don't know if x is positive or negative. So we have to just leave this as the absolute value of x. Okay, let's have some examples of case 2. So examples of 2. Now let's say we've got the cube root of 2 cubed. Well, by the rule, let me scroll this up a little bit so we can see the rule. It's an odd index, right? 3 is odd. Here I should have said n is 4, which is even. So examples of 1 were all for even index. Now we've got n equal 3. That's odd. All right, well, the rule says that we should just get 2, right? And what if we take the third root, the cube root of the quantity negative 2 to the third? Well, the rule says we should just get what is being raised to the third power under the radical. So we should get negative 2. So do these make sense? What is the cube root of 2 cubed? Well, 2 times 2 times 2 is 8. So this is really the cube root of 8, which we know is positive 2. This next one, the cube root of the quantity negative 2 cubed, well, Negative 2 times negative 2 times negative 2 is 3 negatives. That's negative. So this is the cube root of negative 8, which we know is negative 2. You might be wondering, how can you get that? Well, remember, we're saying the cube root of something is when you take the thing you found as the cube root. If you cube it, you should get back what you were taking the root of. And negative 2 cubed is negative 8, so that checks out. All right, and then one more example. How about the cube root of x cubed? The rule says you get x without absolute value. So let's just make a couple final points here. We can always take an odd root of a negative number, which we're showing here. Cube root of negative 8 was negative 2. In the examples from 1, where we had an even index, we can't take an even index, an even root of a negative number. I wasn't doing that anywhere here, right? These were both fourth root of positive 81. The fourth root of negative 81 is not even a real number. So one little thing we could add to this second rule is you get a without absolute value if n is odd, or if a is greater than 0. And that's kind of this case, right? Here we had the fourth root of 3 to the fourth, and the end result was a 3 without absolute value. The reason that happened was because 3 is positive. Okay, we'll quit there. One more video to go. See you in a bit.